Dear students, welcome to the knowledge series. We'll be discussing on operation of crisp and fuzzy relations. As you all know, a relation is of a fundamental importance in all the engineering field. And the relations is basically that represents the similarity. You might have gone through my previous slides related to the relations and also on the fuzzy extension principles. Based on that, this particular segment on relations are involved in certain operations, and these operations are useful in the various applications like in the machine learning, for the classifications or the pattern recognitions, control systems, and so on. Now, when we talk about relations, when there is a relations between two universe of discourse, or maybe the two events that take place, and what are the similarity between that one, we try to identify under the case with respect to unconstrained conditions. And if there is a constrained condition exists, then based on that, what are the different analyses we have to take upon. Now, considering this particular example on the operations of a crisp relations, you can see that there are two universes of a discourse, x1 and x2, and with one element defined with respect to x1 and x2 under the case of universe of discourse x2. Now here it is stated that a crisp set consisting of a subset of order points x1 x2 in a crisp is a crisp relations in the Cartesian product of x1 cross x2. That means if you take a Cartesian coordinates, so everywhere perpendicular to x1 and x2 you are considering. So you will be finding a linear graph. So under this particular case, f of x1 comma x2 is equal to 0. That means all the points lies on this one, corresponding to the x1 universe of a discourse and x2 universe of a discourse. So this particular notations of relations in a crisp set is also extendable to the fuzzy sets conditions also. Now, if you look across the crisp relations, it represents some of the basic presence of just like a crisp operation and the fuzzy operations. There in the crisp operations we have discussed about the association and properties, interactions properties, like that many different properties we have discussed. So based on that, here also we are going to see some of the operations related to the crisp relations. Now, in the crisp relations, we are considering two basic elements. That is, one is R fuzzy set, and another is a S fuzzy set, to explain about the relations. Now, under the condition of these two fuzzy set, we are also considering that all the content x and y is the subset of the universe of a discourse x and universe of a discourse y. Now, when we talk about a crisp relation, you have to know that the dot product the product is under the Cartesian conditions. That means it's a Cartesian product in these situations. So if you look the statement in the crisp and the fuzzy set, the element of A and B, two sets are common, but in relation to two different sets with different elements are considered. So here when we talk about the two sets, even if they are common, but the relations we consider with respect to two different elements. So if you consider A is equal to say A1, A2, A3, and B is equal to say B1, B2, B3, B4. So even if that two products A and B are two different sets, but their elements is being considered under that conditions differently. So if you take A1, A2, A3 and B is equal to B1, B2, B3, B4, so you will be able to find the nearly 8 dot points. You can able to no, not 8 dot point, you will be coming across nearly 12 dot points in the Cartesian points. So like that you will be able to define with respect, because you will be writing if you are taking a mapping with respect to A to B, A1 B1, A2 B2, A3 B, A1 B1, A1 B2, A1 B3, A1 B4, like that you have to define. Now the operations of the Crispr relations, when we defines, if a union operation is there for a given set R, where X and Y is defined with respect to different element, union of a S set with X and Y, the elements, that is also a different elements. So under these conditions, if we are representing, we are taking a maximum value among these two relations. Now when we take intersection conditions, then just like this one, we are representing chi R intersections S of X comma Y is equal to minimum of these two sets. That is how we take into consideration. Complement is nothing but whatever the set is there, it's that set value is subtracted from the maximum value, that is 1. So that represents the fuzzy set complement values. Now containment means R is a subset of S. That means R values are smaller to compared to the S values. So R X of R chi of R XY, that is a subset, that is a fuzzy set R XY is less than chi of fuzzy set S XY. Identity means all the set elements is equal to null, that is equal to 0. So that's one. And if it is equal to E, that means all the elements are equal to 1. So that is a fuzzy set R, and fuzzy set R, that is the represent with respect to E, and the null set with respect to R. That is how we defined in this particular conditions. So here this is a universal conditions, and this is a null condition. Now let us see the example with respect to this one. Suppose a two fuzzy set R and S with respect to two different inverse of a discourse is been taken into considerations, are the two relations defined over the two Crispr set. X belongs to A and Y belongs to B. Now R is defined here, S is defined here. If you undertake in union operation, R union of S is equal to chi of R union of S XY. What we do, we take a maximum of these two values. So if you take element to element, 0 to 0, that means the first element of first row 0 to 1, so you take a 1. Then the second element of the first row 1 to 0, so 1. Like that, if you try to select, we gets the values like this one. When you go for the intersections, we try to take a minimum. So first row to first element, and then you find it as 0. So all value will be equal to 0. That is the minimum element. And if you take a inverse of this one, wherever it is a 0 and you make it as a 1, and wherever 1 is equal to 0, then that becomes the your complement which has been shown over here, complement values. Now we see further the same definitions which has been defined over here with respect to the union operations, intersection operation, complement operation, containment operation, and inverse operations. Now we go to the next point, is the projections. when we talk about projections, the projection of a fuzzy set R projected on Y, R x y, let R projected on Y denote a projection of R onto Y. Then R projection Y is a fuzzy relations in Y whose membership function is defined by mu of R projection Y of the two fuzzy set element x comma y is equal to maximum of the mu R of xy, and that is what we try to see over here. Now if you see the projections, so all the projections which we try to see over here is that this is the x, this is the y. Whatever the value you are taking under the projections, all the maximum value under these relation conditions you are going to select. That is known as projections. And if you are taking n array relations projections, then in that case you will be having if number of arrays are more, automatically that number of arrays projection values are also coming under the maximum of a mu r of xy. Cartesian product, it is straight way explain is that it is mu of two fuzzy set A cross B of xy. Mu r of xy is equal to mu of A cross B xy is equal to minimum of mu A of x and mu B of y. So under this particular conditions, the fuzzy set relations of the two sets value is been defined with respect to the minimum operations, where you can try to see that all the elements belongs to A and B is represented in terms of x and y. So here when you talk about fuzzy projections, when you compare with the previous projections shown, it is the same thing is that x projections, when you say that R projection to x, that is mu of R projection to x is equal to y comma maximum of mu r of xy. That means you will take into considerations y comma maximum of mu r of xy, such that xy belongs to x cross y. When you talk about a y projection, y projections, then r projection y, mu r of r projection y, such that because it is on the x coordinate, so x comma maximum of y mu r of xy. So mu r of xy, so maximum of y you are taking on the x point. So that's how mu r of xy, such that xy belongs to x cross y. So this is known as a y projection, this is known as a x projection conditions. When you talk about a total projection, both y and x, then mu of total projections x comma y is equal to maximum of x and maximum of y, where mu r of xy is such that xy belongs to x cross y. Now let the relation R be the fuzzy relation defined by the relation matrix given below. R is equal to x1, x2, x3, and y is equal to y1, y2, y3, y4. So that is how we are defined. So find the R cross x and R cross y. Let's see based on this condition. When we talk about R projection x1, R projection x1 is nothing but the mu r of x1, that is a maximum. What is maximum? Now if you see that this is a x max, so all the element which is in the x point. So here if you try to see x point is that 0.1, 0.2, 0.3, 0.4, no, 0.1, 0.2, 0.4 and 0.6. That is what you are seeing here. So among this one you are selecting value that is equal to 0.6. Similarly for x2, among this line you find the value close to 1. And third, here you are finding 0.6, the maximum value. So these three are the maximum value. But when you talk about y projections, so this is y projection. So all the vertical conditions you have to take. Among this one you have to find it is a maximum. So it is 0.6. That is what you have shown here. In here 0.6, here 0.7, here 1. That is what. So this is known as the projections identifications with respect to the different cases. Now we go to the another discussions with respect to examples. Before that, a fuzzy relation or a general set relations is nothing but the element relations in the order pair. So this is a generalized concept, is that whatever the pair is being given, it is in that order pair we take the relationship conditions. Now here given two sets, X is given 1 to 5 elements, Y is given 2, 7, 9 elements. So these are the two coordinates over which you are selecting these elements, and you are being asked to find the relation R between these two elements X and Y. So our relation, how you find the relations, that is X comma Y, such that Y belongs to inverse of X, and XY belongs to inverse of X cross Y discourse. So here Y, but here X instead of XY, X comma Y, here we are given Y is equal to X plus 2. That condition, this condition satisfies the inverse of a discourse X cross Y. That is what I mean to say. Now relation, this is what I mean to say, the X cross Y, where X comma Y says that X belongs to X, Y belongs to Y. That's how we define, or X comma Y belongs to X cross Y. That's how we talk with respect to the when we try to define in terms of a product. So X cross Y is how we define. We have two relations, 1 2 1 7 1 9 2 2 2 7 2 9 5 2 5 7 5 9. That is what written over here. Now this is the complete set groups. Now under this set groups, 1 and 2 are the two different elements of the X and Y sets, and which is the subset of the individual X and Y universe of discourse. Now here, which among this one, which is the one which satisfies this condition, Y is equal to X plus 2? That means you have to find a value, if any value of Y, say 2. If this is 2, you take a case 1, X is equal to 1, 1 plus 2 is equal to 3. If you find any value which is 1 comma 3, that satisfies the conditions. So here nothing is there. Then you look for the 2 plus 2, 4. So 2 and 4, is there any? No. You look for a 5 plus 2, 7. So 5 plus 2, here is a 5 and 7. So this satisfies the conditions from this group. So this is the actual unconstrained relations. Now this can be represented in the matrix forms, just like 1 to 5, 2, 7, 9, and among this one you try to put all other as 0 and the one which satisfies the condition as 1. So the relations that satisfy insert as 1, otherwise the others are 0. This is known as a fuzzy relations. Now let's see the another case. Now here find the relations R where X of comma Y such that Y is equal to X state. Y is equal to X state, if you try to say for R is equal to 1 1 2 2 3 3, then you find that if you try to plot the matrix, you will find that all the linear points are nothing but a 1, others are 0. Now let's go to the another example with respect to the case on the associations, interconnections. Now relation R is given as an associations or the interconnections between the first color and the state, represent as a crisp and a fuzzy relations. So here the two part is being asked, how you represent in terms of a crisp and how you represent in terms of a fuzzy. As you know that the crisp always represent in terms of a 0 and 1, and 0 or 1, and fuzzy relation is always represent in terms of 0 to 1. That's the difference. Here 0 or 1, here 0 to 1. Now here given the X set with the color green, yellow, red, and y set with unripe, semi-ripe, and ripe. That's the fruit color and the state is being given. Now when you try to represent the crisp set, whichever is represent the conditions with respect to, say, if you know, we know that whenever a fruit which is you take a mango, when it is in the green color, that is the unripe state. Whenever it is yellow, it is a semi-ripe. Whenever it is nearly to red, it is a ripe state. So only under this condition we put it as 1. Otherwise all other condition is 0. That is a green in the semi-ripe or a ripe. It is not these two are not a valid condition. These is a valid condition. That's how we have been putting the state of fruits and its color. Now when we try to put in terms of a fuzzy, the things become more clear. We cannot tell that ripe is in the case of fruits. If it unripe is the actual valid condition. If it is in the if the fruit is in the semi-ripe or in the ripe state under the class of a green, we cannot put always we cannot put statewise 0. We can put in terms of some values, say 0.5. The particular mango is semi-ripe or it is in a ripe state, equal to 0. It is unripe state is equal to 1. So green is in a 1 means it is a true conditions, but semi-ripe means it is not a actual true conditions, and ripe is not at all the true conditions. So that's how we represent in terms of some certain values. Now we go to the another case with respect to the fuzzy relation. Fuzzy relations are of the following in use of a discourse x and y. X is defined with respect to a disease, typhoid, viral, and cold. And here y is defined in under the typhoid case you find a runny nose. Under the viral condition you have a high temperature, and whenever a cold you will be shivering. So this is a valid condition. It is a 1 or here represent in terms of some value. So here it is written that typhoid under the running case it is 0.1. Here it is a 0.9, 0.8. Viral case also defined separately. So you can look into the condition is that if it is a cold and shivering, if it is 0.6. So you can say that the patient's whether he is shivering. No, it is not too much shivering. So you can say 0.6. Whether it is high temperature, no. So they will measure a certain temperature is a 0.5. Running nose, yes, it is more. So that's why they are close to 1. Like that, the fuzzy relations try to give a validation, try to give a or represents the matrix in such a form that it gives some understanding, it gives some output, it gives some idea about what exactly this particular relation indicates. Fuzzy Cartesian product. When you take a fuzzy Cartesian product, if a two fuzzy set A and B is been selected, the relation R, it is defined with respect to A cross B, that is equal to X and Y. Then this particular Cartesian product A cross B, it is defined as if we define A1 in one side, one category, B1 in one category, A in one category, B in one category, and there how we try to fill the matrix. So here to understand this one, let us see this mu R of x comma y is equal to mu of A cross B of xy, where x and y is the element of a fuzzy set A and A cross B. That is a minimum operations of a mu A of x and mu B of y under the conditions of the relations R. So here two relation is being asked, A comma 0.2, A1 comma 0.2, A2 comma 0.7, like this one. where A1 is the element and the 0.2 is nothing but a membership, because it talks about a fuzzy Cartesian product. Under the fuzzy Cartesian product, we don't need to worry about how it is represented, because it is a straight way we can able to understand that it talks about the point with respect to set and element. But when you talk about a Crispr case, we no need to define in this particular order, where the two different elements is being defined, so that it will be able to give an idea about how that particular relation has to represent. So under that particular case, suppose if you are taking A will be taken with the 2 value, B will be taken 2 value, but those 2 values are the X and Y, here X and Y. But here X is X and Y is represented, but every X will be having its own weight, that is a membership weight it is. R is equal to, so here we define A1, A2, A3, B1, B2, B3, and corresponding to that one we try to put the value 0 0.2, 0 0.7, 0 0.4, like that values. So that's how we try to represent the different values of the fuzzy relations under this particular case. Now when we try to look across the representing the value with respect to the Crispr set under this particular condition, the Crispr set, how it is going to deal it, the Crispr set will try to deal with respect to these X and Y here, X and Y here, under the two set A and B, and that's how it try to map, and thereby wherever the relations is coming with respect to X and Y, that's how, that is element to element, it will try to look for the minimum. A will be having a X and Y, B will be having X and Y, then you will take the minimum operation. But here we try to take X is separate, X has a values, different element value, Y has a different element value. So we define X here and we define Y here, or we define A1, A2 here and B1, B2. Corresponding to that one, we try to map. Say A1 means A1, B1. A1, let us take here, we are representing A1 and B1. So A1 is 0.2, B1 is 0.5. So among this minimum operations, so minimum value is 0.2. Then A1 0.2 and B2 0.6. Let us take A1, B2. So A1 and B2. So we take this one, this value. So among these two, A1, B2, this minimum value is 0.2. Like that we fill everything. So the calculations of mu A1, B1 operations with respect to these values is nothing but mu A of A1 and mu B of B1. So you will be finding in this particular case how I have explained to you with respect to the first case of 0.2 is explained in this particular sections for a easy understanding. So that is what exactly means about the discussions with relation to the today's point. We discuss the operation of a crisp and a fuzzy relation. So with this we conclude here. Thank you.